Remember, the course today says common elements of IoT, and we're picking just one of the 4 distinct ones. We're looking at sensors and devices, connectivity, data processing, and the user interface. So, sensors and devices, just like I talked about it before, they are technical components for the qualitative or quantitative measurement of certain chemical or physical variables. I remember that day that when I mentioned this definition, I felt it was too heavy. There are simpler terms that define sensors, and then that's why I put this. They are devices that collect data from their environment. It could be as simple as temperature, it could be as simple as proximity, humidity, and so on and so forth. I went ahead to show you an example. Just a phone. See how many sensors the phone has. Okay, and that's sensor. After sensor, I talked about connectivity, and I mentioned these are the 3 most popular connectivity platforms or connectivity engines. The cellular, which is what we get from our SIM cards, the Wi-Fi, which is what we get from routers and modems, and Bluetooth for peer-to-peer connection. And then we looked at data processing. Now, data processing just talks about when those data has been collected from the sensors, and then those data has passed through connectivity to the cloud or to the application interface that is meant to process the data. Okay, and most of the time is the cloud platform that helps you process this data, filter out what needs to be filtered out, run some queries and do some data analysis, and then give you results. And where does the result fall into? The result falls back into the user interface when required. It's not every time that the user interface is required. Sometimes these things happen automatically without the intervention of the users. Other times, then the user has to perform some form of input or some form of interaction with the ecosystem. So this is what the user interface we're talking about looks like. The one on the far right, the orange color, is talking about heat, a thermostat. So it's showing you the current heating in the environment you are monitoring, and then it's giving you an option that you can turn on the fan to cool the thing down or increase the heat. All of this are the user interface side of Internet of Things. I added another picture that shows you how lights has been used, cameras, and the rest of them. Okay, so now let's go straight into today's section, sensors. Sensors. I defined the sensor before, so there's no need of me defining them again. Here it says sensor outputs valuable information, and if they are connected to a network, they can share data with other connected devices and management systems. The sensors are crucial to the operation of many today's business. All of this is long story. We already know what sensors do. If you don't know what sensors are for, you can please let me know so that I might go back again and talk about it, but personally with you. But we've hammered on sensors for quite some time now. So let's look at what those sensors are. Let's evaluate some of the sensors and see. So here I'm going to be mentioning 4 of the more popular types of IoT sensors and how they've been used. And the first one on that list is the temperature sensor. Please pay attention to that icon, the picture by the lower right corner. You see the sign for the temperature sensor. It's an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. I don't think I need to show you pictures or say more about temperature. You already know, because most of us have encountered the non-touch temperature sensor that they are using to check people at everywhere, from buildings to hospitals to cars to buses, public transport. They normally do this, put that small thing that looks like a gun on your head to check your temperature. And then we know that there are different types of temperature sensors as well. So this says here that some temperature requires direct sensor, or some temperature sensor requires direct contact. So sometimes you touch the object you want to measure, other times you don't need to. Those ones are called non-contact temperature sensors. So these are a couple of sensors that exist. The ones we embed in devices are the smaller ones, those black ones under. They are temperature sensors as well. So you can see the different pictures of different temperature sensors. There are more than this. These are just the ones I could put into the same picture. Moving on from the temperature sensor, we'll look at the next one. The next one, Adebayo says, I can't hear you anymore. Is everybody facing the same consequence? Is everybody losing audio? Or is only Aziz that's losing audio? Okay, it's only Aziz that's having problem. That means your network is having issues already. So please try refreshing. Try refreshing. Okay. So we're looking at the next one here is my humidity sensor. The humidity sensor, we use it to measure the water vapor actually in the air or in any other gas. So you commonly see these ones in HVAC systems, heating, ventilation, and air conditioning. That's where you find humidity sensors that enables you to measure the amount of water in the air and other gases available. That's what your humidity sensor is all about. Okay, they can be found in many other areas, in hospitals, in meteorology stations. That's what they use in predicting when rain will fall. They measure the amount of water vapor in the air. All these tests is how we get to know that prediction of when it will rain and when it will not rain and so on and so forth. That's a very practical example of where the humidity sensor is used. Now, some humidity sensors vary in size and functionality. Some can be in handheld devices like your smartphone, while others can be embedded in some large systems like the quality monitoring system, the air quality monitoring system that you use in some hospitals and some big buildings. So medicals use it very well, even automobile industry use it very well as well. Okay, then there are two major types or two major groups of the humidity sensor. You either have the relative humidity sensor or the absolute humidity sensor. The relative does some form of calculation by comparing what it is measuring at a particular temperature to the maximum amount of humidity for air at the same temperature. So if the temperature is 37 degrees, whatever it's measuring at that time versus the maximum it can ever measure, it uses it to calculate what the relative humidity is. While the absolute humidity is measured without reference, it just measures what it has there and gives it out. That's the difference. I hope we got that. Relative measures and does some form of calculation, while absolute just measures and gives you the details. And that's a picture of some of the humidity sensors. Some you can embed into other devices, others you use directly on the surface you want to use it. Okay, and then remember you can also use that humidity sensor to test for you can use that in the agricultural industry as well. Okay, so the next one we're looking at is the pressure sensor. It says pressure sensors or detectors or transducers are electromechanical devices that detect forces per unit area. In fact, pressure is calculated as force per unit area. So that's where the definition of the pressure sensor comes in. Okay, the pressure sensors will check for changes in gases and liquids. Okay, that's what it checks for. So when it sees those changes, it communicates them to the connected systems. The common places where we use these sensors are maybe in leak testing, to test for leakage in things. You also is very useful to the liquid industry, the oil and gas, the water board, and the rest of them, water manufacturing, and so on and so forth. They use the detection in the fluctuations or drops in pressure to monitor. Okay, they are divided. They are devices that translate the magnitude of the physical pressure that is being exerted on the sensor into an output signal that can be used to establish a quantitative value for the pressure. Here is mentioning the different types of pressure sensors available. Okay, so we're going to look at some of them. These are different technologies for pressure. Now we're looking at the potentiometric pressure sensor. This is the one you have things that look like capsules. So this is used to measure relatively, do some comparison between what is there and what needs to be. It uses the concept of a potentiometer. The next one there is the inductive pressure sensors. This one's, instead of using the capsule method or the Bourdon tube, this one uses a linear variable differential transformer. It's called the LVDT. Okay, in the inductive has things like primary and secondary coils of transformers, so use it to measure pressure. Then you have the capacitive pressure sensor. It uses the concept of diaphragm. Okay, the other one, the piezoelectric, you can use that to generate or to measure pressure by the electrical potential difference generated. So when a material is subjected to stress, the pressure applied on that device or on that material can be measured using such technology. The piezoelectric pressure sensor. The other two, the strain gauge and the variable reluctant pressure, as well, they are used to measure using the diaphragm method as well. Okay, so those are some measurement technologies that we have. As for types of pressure sensors, these are the common types of pressure sensors. It doesn't start and stop here. There are other ones as well, but this is what you get: the aneroid barometer sensors, the manometer sensors, the Bourdon tube pressure sensors, the vacuum pressure sensors, and the seal pressure sensor. These are the different types. Now, the important takeaway you get from this particular sensor, pressure sensor, is what it does and where it can be used. So, application of pressure sensors, where it can be used. Now, the automotive brake system and collision detection. Some of us that drive cars, that have their own cars, or that have rented cars before, that understand how cars work. Let me ask a very simple question. Can you tell me the use of the pressure sensor for this first item, automotive brake system and collision detection? If you understand what the pressure sensor is, can you tell me one practical example of how the pressure sensor is used in the automotive brake system or collision detection? Are we still there? Hello, are we there? I'm asking for examples of how the pressure sensor can be used in the automotive brake system or collision detection. If I mention it, it would be an aha moment for you, like, oh, so this is what it is, because you know it, just that you have not been able to label it. People have not been able to label it. With our newly connected cars, thank God someone has just mentioned it. Mr. Jude has just mentioned it. I thought I was alone in this knowledge. Airbags. The airbag itself can only pop out, can only come out when there's some form of pressure, some form of collision. So it has been configured in a way that when there's a collision, the pressure triggers the mechanism that controls that airbag. Remember, there's a simultaneous event happening. As the collision is happening and the pressure is detected, a message is sent to the particular device responsible for filling the airbag itself with air, because that air is not inside the bag every time. If you open that airbag compartment, you see that it's folded there, and there's something responsible for filling that air in. So this is the coordination we're talking about for Internet of Things. Is when those devices are now connected to the internet, then you understand how things can work out. So airbags is one of them. Another one is the hydraulic brakes, your ABS system. Okay, uses sensors as well. Okay, the next item on that list says the automobile engines. If you understand the concept of automobile engines very well, you understand that it is sensors that decide the mixture between air and fuel. Okay, so oil pressure as well. For the persons who understand automobiles very well, if you have heard of top dead center, the TDC, it is sensors that detect TDC and helps you know when the piston would start going down immediately and when it will stay there. The next one here says ventilators. Of course, we know how the ventilator thing works. We understand how the air in the ventilator is being regulated, okay, so that it doesn't suffocate you that is using it with too much oxygen or too much air. So these are different ways that the sensors have been able to be put to good use. In this case, the pressure sensor. Okay, there are other ones. The other ones say tank fluid levels. Those gauge that show you the level of a tank. Also, pressure sensors are deployed. The concept of washing machines with the high efficiency washing machines, the industrial washing machines, some of them have sensors embedded in them that can tell how much water they should add in order to wash clothes. Okay, the last one there talks about wearable devices. Okay, I've seen that firsthand, where you can use wearable devices to monitor the pulse rate using the pressure sensor to monitor the pulse rate by measuring small changes in air pressure. Okay, so mostly used for older people, for monitoring them to know when they are still okay and moving around and when things are not the way they should be. So moving on from, okay, yeah, good, smartwatches as well that uses that. So it won't work if the load is too much. Okay, now you understand where the sensor thing comes up. When you load it too much, it doesn't move because the sensor is telling the electronic part of it not to continue operation. So we actually have real life examples of all these things. It's just now we're putting names and definitions to them. Okay, these are examples of the pressure sensors that we have. These are usually embedded into other things. Okay, then moving forward, we have proximity sensor. Your proximity sensor are used for non-contact detection of objects near the sensor. These types of sensor often emit electromagnetic fields or beams of radiation, such as infrared. In all essence, the sensor detects the presence of an object. The object is usually referred to as target. Okay, so when the target enters the sensor's field, there's usually a field where the sensor is looking at, where it is measuring. When an object enters there, it detects it. So it's depending on the type of proximity sensor. It could be sound, it could be light, it could be infrared radiation, it could be electromagnetic field. These are the things it can use to detect objects. Okay, this talks about it. Proximity sensors are used in phones, recycling plants, self-driving cars, anti-aircraft systems, parking sensors, top dead centers or camshaft sensors, in reciprocating engines, and all others. Okay, now let me give you a practical example. I'm sure when I mention that, you should understand it very well. You notice what happens for those of us who use smartphones. You notice what happens when you take a call. Immediately your phone gets close to your ear, it goes dark. It doesn't let your ear touch the screen and disrupt what's happening. That's a proximity sensor. So whenever the call activates, that means a call is going on, and you bring the phone close to the body, it stops you from accidentally touching things by triggering the turn off the screen. That means just put the screen off so that it doesn't disturb. Turn off that touching the sensor itself or touch. Now that's a practical example of proximity sensor. Apart from the ones we use for security, where if you walk into a place and you get so close to a thing, the alarm starts beeping. This one is a typical example. Most of us see that every day. Whenever you pick a call and put it in your ear, you don't hear any other thing anymore. As in, you don't see your body touching the phone and making sounds. Okay, they can be used to recognize air gestures as well. Proximity sensors have grown to the point where they can recognize when you make gestures in the air. Okay, and also things called hover manipulations. Those are the capabilities of modern day proximity sensors. Now there are types to them as well. You have inductive proximity sensor, you have capacitive, you have ultrasonic, you have infrared. There are more than this. These ones are just the notable mentions. The inductive, the capacitive, the ultrasonic, and the infrared. Okay, so that's that, and these are all proximity sensors. There are usually there's not much electrical part of it. You just choose the technology you want to use. For example, if it's infrared, you use infrared technology to detect. If it's magnetic, you use magnetic to detect. So these are all typical examples of proximity sensors. Okay, the proximity sensors as well. I have one physical device. I'll show you at the end of the class when I get off my slides. Okay, now other types of sensors worth mentioning. You have the level sensors, you have the accelerometer, you have the gyroscope, you have the infrared sensors, you have the optical sensor, and the last one there, MyThings IoT sensor. The MyThings IoT sensor is just a self-contained sensor, battery powered. It has multi-purpose. It allows you to capture different types of data, like you can combine acceleration, temperature, humidity, pressure, GPS, everything combined together. The sensor can capture such. Okay, if you look at the pictures very well, I'm sure you can understand, you can relate the picture to the sensor. The one that looks like a car, the one on top, that should be your accelerometer, right? Remember where we use that? Typical example where we use that is this the speed delimiter. These normal buses that run 100 kilometers, then the company will install something that will reduce that will make sure they don't exceed a particular speed. Okay, so the accelerometer sensor, is part of the things that is inculcated in that device they use to limit the speed. Okay, the level sensor, I'm sure you understand the one that's the level sensor, the one that looks like a teardrop by the far right corner. That's your level sensor. You are using to detect the level of substances like water, powder, and all of that things. Okay, that's a level sensor. And then you have things like the gyroscope. The gyroscope is the one that has the multiple circles in together, the one under, right by the side of my things. The gyroscope is used to measure your angular rates or velocity when you're moving something around, gyration. The phone has that thing very well. Even the car navigation system has that thing as well, that helps you know when you're moving out of place, or when you, yeah, remember the phones that when you shake the camera something does, or some games that when you shake your phone it performs an action, and that's the gyroscope working. Or when the phone is sleeping and you pick it up and the phone wakes up, that's the gyroscope doing some things. Okay, then the gas sensor, the gas sensor, the one that has the gauge on top, the black one in the middle, that's the gas sensor. You can detect changes in air quality, including presence of toxic, combustible, and hazardous gases. The infrared sensor is the one that has a line and those things that look like wireless. It's used to detect infrared radiation. They can be used to measure heat emitted by objects. It can also be imputed into or embedded into other sensors as well. For example, proximity sensor also uses infrared as well. So that's that. The next one there is the optical sensor. The optical sensor is the one that has the lines that looks like an eye but has lines everywhere. The lower right corner converts ray of light into electrical signals. Okay, you can use optical sensors in so many industries. Vehicles use it to recognize signs on the road, obstacles, for all these new modern driverless cars. Okay, so these are optical sensors. Then I mentioned the MyThings IoT sensor. That is a combination of a couple of sensors. For so many sensors that work together. Okay, do we have any questions? Okay, so you're not seeing my full slide. Okay, let me see if I can reduce this again. That should be better now. Someone asked a question. See, what category does motion detector sense of falling? Now, the motion detector could be one of many things. Okay, the motion detector could have proximity sensor in it. It could have infrared sensor in it. Do you understand? It could have pressure in it. There's so many, and there are motion sensors. Okay, I just mentioned, remember when I was talking about this, I started with the more popular types of sensors in the IoT workspace, right? In the Internet of Things ecosystem. So the motion sensor is one of the sensors as well. I know, yes, that one has been produced already, but before now it used to be a combination of other sensors that make up the entire motion sensor. Okay, so let's see, any other question? Mr. Aliu Muyudin, are you seeing the screen now? Are you seeing the full screen now? I've tried to reduce the screen myself. Don't worry, you still get the slides so that you can get first-hand information from the slides yourself. Okay, so let's look at the hardware considerations. As much as you're utilizing these sensors, you're building them, you're buying them to implement your own infrastructure, there are some considerations you have to consider, or there are some things you have to consider. And one of the major things you have to consider is battery life. Battery life. I remember the first time I tried to do some form of Internet of Things. I got a small robotics car, and I was trying to make sure I'd be able to control it via the internet. And I noticed the battery variable was making me mad. I was using finger battery, and at the end of the day I wasn't able to achieve something specific. Something as simple as let the robot move from point A to point B. The first time I'll try it, the robot will pass, I say, okay, the battery is strong, let me reduce the variable. I reduce the variable, the battery would have drained a little bit, the robot will not get to destination anymore. So I was paranoid. Now this is part of the things you have to put into consideration. Whether or not the sensor would have power is something you must think about. And remember, some of these sensors might be globally placed. So imagine you have a sensor in the village, in the farm in the village, and you are in the city. The sensor has to be able to communicate to you. And does that mean you will draw electricity to the farm? No. So that's where the battery considerations come in. And the batteries you're thinking about are batteries that should be lasting you months and years. Okay, so this says all of these battery considerations also influence the kind of connectivity you choose. For example, if your humidity device you put in the farm is supposed to send message to your cloud platform directly, imagine the kind of connectivity it should have. It should be able to have long range connectivity, and that drains battery life as well. Okay, so the point is that hardware decisions are extremely important, and there are many considerations to take into account, which all stem directly to the kind of use you're putting your device to. So if your device is supposed to communicate long range, you should be able to find appropriate power for it, except you are ready to be doing the every week you go and change battery. So if you have the IoT system spread across Nigeria, every week you must go through all your states, all the Nigerian states, just to replace battery. Now that's not a good design. Okay, now one of the first considerations is whether or not the sensor or device you will be using will have power available. Okay, so you must think about that. If your hardware is battery powered, you want it to last on battery power for a long time, sometimes years. Okay, this one talks about over the air firmware updates, OTA. It is a welcome development to think of your device as once it's done, no need for upgrades. But what about the changing times? What about the new things that come up and you need to upgrade your firmware? Now, do you now say after deploying to 36 states or to different continents that when it's time to do a firmware upgrade, you have to physically go to those continents just to upgrade the firmware? No. That's where the over-the-air OTA firmware upgrades come in, or updates come in. So you should be able to change the firmware. The word firmware is in between hardware and software. Okay, the firmware is the program that is put on the hardware of the device, basically telling it how to function and perform. As the name implies, it is between hardware, which you can't change once it has been manufactured, and software, which you can update with relevant ease. Okay, so updates are critical tools in addressing issues that may come up. Whenever there's an issue, you can use updates to solve it. But something like the OTA firmware update comes with a how would I put it? It comes with a downside. It comes with a disadvantage, because that's one of the vulnerable ways that hackers can get into the system, providing such things as corrupt firmware updates. Now, when it is a corrupt firmware update, rest assured that that device is already being taken over. Okay, those are the considerations for hardware. And then the IoT gateway, which is the last part of our class today, is the last thing we're going to handle today. Remember, the IoT gateway is standing like amongst the IoT devices, but is not fully integrated into the IoT devices. Neither is it integrated into the connectivity device that comes after sensing. So the IoT gateways are just how would I put it? They help you bridge the gap between the sensors and the destination, which is the cloud. That's what your IoT gateway is responsible for. Okay, we're looking at what makes the connection possible. Those devices you have embedded into the soil, into the farm, are they going to connect directly to the internet? Are they going to connect directly to your satellite? Now the IoT gateway acts as the bridge between sensor and the cloud. Okay, so instead of the sensors talking to the cloud directly, they will talk to the IoT gateway, and then the IoT gateway can move it to the cloud as it is. So this is what that is explaining. It said nearly every IoT system needs some way to connect its sensors to the cloud so that data can be sent back and forth between them. But the thing is, what benefit is there to taking the extra step? What benefit is there to putting a device in between the sensor and the cloud? Now let's go through the benefits. You're looking at battery life. I remember when I was talking about the battery consideration, it's impossible for you to think of a battery that will last you years and also be thinking of that device, that small device, is going to be connected straight to the internet. It will consume more battery life. So if you have a farm and there's a farmhouse and the farmhouse has electricity, it means the IoT gateway can be in that farmhouse. Now the communication will now be between the sensor and the IoT gateway in the farmhouse. The gateway can now be the one to connect to the internet. Okay, so that's one of the benefits, the battery life. Okay, the longer the range you need to connect, the more power you need. So the IoT gateway can bridge that gap. The next one there says varying protocols. Now let me still continue using the farm as an example. It's not only one type of sensor that ends up in the farm. So you can have the moisture, you have the temperature, you have sunlight, and so on and so forth, and all of this have their different protocols. They might not be able to come together to communicate useful data, but the gateway has the capability to understand and read those data before transferring it to the internet. So that's where the varying protocols, the power of the gateway comes in. So all the different sensors and devices can use the varying transmission protocols, like the Wi-Fi, the Bluetooth, the Zigbee. So some devices can connect to the gateway via Bluetooth, some can connect via Wi-Fi, and so on and so on and so forth to communicate, while the gateway is responsible for sending it to the internet. The next one there says unfiltered data. Now sometimes devices will generate too much information. Let me give you a typical example. Imagine the camera, CCTV camera. Imagine if the camera was intelligent enough to know that it doesn't need to record when nothing is happening. Okay? Currently, the normal CCTV cameras, they just keep recording, and the hard disk is filling up. Okay? That's enough data going to the hard disk that is not useful. So when someone comes in the morning and wants to come and review, they will have to watch the whole day to even know what happened in the day. But what if the camera had some form of sense to know that you only start recording when something is about to happen? So those are the unfiltered data we talk about when the sensors are sending a lot of information. So the gateways help by filtering such information and then sending across to the cloud the important one, the necessary ones. Okay, so the gateway can pre-process and filter the data being generated by the sensor to decrease the transmission and processing time. You are using your IP cam over the internet and it keeps recording daily and keeps sending you that data. Of course, you know what it's consuming. The second to the last there says high latency. The latency we're talking about here is time of reaction. The sensor that is very far away, connecting to an internet that is in a different country, and then it needs an instant action. For example, let me go back to my camera. The camera just noticed something, and the camera is supposed to send that data to the cloud so that the cloud can now talk to the alarm for the alarm to start ringing. But you notice the distance it has to cover. Sometimes the gateway help bridge that gap. The gateway can pre-process and send feedback to the necessary system to carry on. Okay, so all those truth or life or death situations is where the gateway now comes in. So the emergency shut off for a valve when there's a sensor that has noticed something, the emergency shut off will be carried on by the gateway before it even starts going back to the cloud platform and then giving the information to the cloud platform. Now that's where, those are the ways the gateway is important. I don't think I need to explain the last one. Security. Security has always been a thing. You cannot have security embedded on all your sensors and all your devices. Sensors will now be costing you thousands. So the IoT gateway provides that security for all the sensors. Now imagine that you have 1,000 sensors in the farm, and that 1,000 sensors connect to the internet. That means that 1,000 sensors is a potential weak chain that a hacker can come into the system. But when the gateway is involved, every sensor is locally connected to the gateway. So it's only the gateway that goes to the internet. Of course, there are some security issues to using such things, because when someone hacks the gateway, the person has automatically gotten every part of your sensor. Okay, so but the gateway provides the first level of security to your entire system. Okay, so that's what we're looking at. That's what we've looked at today. For a review of what we have been doing so far, we have talked about the IoT components, the sensors, the connectivity, the data processing, and user interface at the beginning, a summary. We focused only on sensors today, and we talked about the popular types of IoT sensors: the temperature sensor, the humidity sensor, the pressure sensor, and the proximity sensor. We went ahead to look at the device considerations, the battery consideration, the OTA, over the air firmware upgrades, and finally we looked at the IoT gateway. All of this sums up the topic, or the first part of the topic: common IoT devices or common IoT sensors. We've looked at sensors. We'll talk about connectivity in our next class. After that, we'll deal with data processing and then user interface. All of this form the elements of IoT, the major components that we'll look at. Any questions so far? I don't think we should be having issues with sensors anymore. Do we have questions from all the things we've talked about so far? Please ask your questions now. You know me now. If you don't ask your questions, me, I'll ask mine. I would still set up the assessment as it is. Okay, it looks like there are no questions. So it means that we all understand what we have been doing so far. You understand everything that I've talked about so far. Okay, so let me ask my own question. Samuel says he has been having network issues. Okay, maybe when I give you the slides, you would read and understand better. My own question is this: which sensor or which sensors do you think is responsible for those automatic doors at hotels that open when you come close? Those hotel doors that open when you come close to them. Okay, proximity sensor. Okay, proximity sensor. Everybody saying proximity sensor. Okay. Is there anybody else that have a contrary answer to that proximity sensor? Or is it only proximity? Mr. Jude said pressure on the floor. Yes, pressure on the floor too. When you walk to a certain distance in front of the door, some of the doors will see you using proximity, some of the doors will feel you using the pressure. So the pressure on the floor, they've put a pressure plate there that when you step on it, the door opens. Okay? So you should understand that. Now, okay, next question. Elevator. There's this constant thing about elevator that when some big elevators, intelligent ones, when they want to close and you put your hand in between the doors closing, it will open back. So which sensor do you think that is? When an elevator door wants to close and you put your hand in between, it normally goes back. So which sensor do you think that is? Which sensor do you think controls that particular technology? Or you've never thought about it? Proximity. Okay, people are saying proximity sensor. Okay. Someone says pressure. Okay. Now, Mr. Jude, pressure in what sense? Remember, I'm talking about when the door is about to close and you put your hand in between the door and then it opens back. So there's usually some form of interference between the door closing shut and then it opens back, understanding that there's somebody there that wants to enter. Okay, good. It's not meant to feel any form of obstruction in between. There's not supposed to be anything sitting or standing in between the two sides of the door closing. That's why the intelligent elevators don't slam people. Not like some of the ones we have in Nigeria that if you make mistake and you are in between, the door will first jam you before it will go back. Some just feel that presence and then they go back with the measurements in the pressure in between or infrared sometimes. Okay, so thanks for joining the class. I said I was going to show you my sensor, the ones we're going to be making use of when we get to our physical class. Okay, so if you can see what I'm showing you now, this is an infrared sensor. Okay, now there is this same device as well that instead of using infrared, it uses ultrasonic. Okay, so this one we can use this to simulate our proximity. So whenever I attach this to, if I program it to do something when someone comes closer, that's what it will do. So if I configure this to connect to my alarm system and make sure that when someone comes a certain millimeters or a certain centimeter in front of the device, then the alarm starts ringing. So this is your proximity sensor. While this one is a color follower. This particular sensor understands color. Okay, so you can use this to follow specific lines. In the automotive industry, the self-driving cars that understand the lines on the lanes, that's some part of technology they use, where the car can drive itself by using the lanes on the left, on the right, it can navigate properly to different places. So these are different sensors. There are many of them. I have a ton of them that you can use to deploy some simple electronic stuff, some simple IoT things that you want to use, some manual ones other than the ones that we buy that the device is already encoded with a lot of things like the IP cameras and the rest of them. So thank you very much for the class today. We started quite late. I need us to maintain the 4:30 so that we can close 5:30. I know some of us will be on the road, some of us want to go home, so that we can achieve what we want to achieve. Next class on Thursday, we're going to be talking about connectivity. We'll break down connectivity a little bit. So some of us that didn't get it before, when we talked about networking, you will get more of it. Remember I said we'll talk about the LPWN as well. So thank you very much for being punctual. The names are usually the same, and I like that. The other persons, I don't know where they are. The regular persons, the Debesin, Amy, Samuel, Jude, Tonye, Aziz, Aliyu. It's good to have you. Peace as well. There's one other person, Joy, that's not here. I don't know what happened to her today. So thank you very much for joining my class. Don't worry, today we're not having assessment today, because the classes of today to Thursday and Saturday are the same, the common elements of IoT. So we're going to have our assessment at the end of the week. It will be a short assessment, since I'm beginning to understand where I should do more explanation and where I shouldn't. So assessments will reduce in frequency. So thank you very much for joining the class today. Have a lovely day. For those of you who are still on the road, safe back to your respective places. Are there any questions? I'm seeing some people who want to ask questions. If there are questions, you can drop it as well on the platform, on the WhatsApp platform. Anytime, I'll get to it. Thank you once again and have a lovely evening.